Now that we have looked at the partial fraction decomposition as two examples, I'm going to come back here now to number 33. And we get dp dt is equal to 0.0015 p times 150 minus p. And as we've done in the past, the first step to this is to separate the variables. So I'm going to write this as dp over p times 150 minus p is equal to 0.0015 dt. Now that the variables are separated, I need to do one more step before I integrate, and that is to change this fraction into two fractions. So I'm going to write this as 1 over p times 150 minus p is equal to a over p plus b over 150 minus p. And I'm going to try to figure out what the values of a and b are, as we did in the previous examples on partial fraction decomposition. So now I'm going to multiply 150 minus p and 150 minus p. And I'm going to multiply by p here and p here. So now I have common denominators. So my numerators must be equal. 150 minus p plus b times p. Now, when I distribute here, I get 150a minus ap plus bp is equal to 1. Notice there are no p's over here. There's no p's. So this 150a has to equal 1. So a is 1 over 150. And then minus ap plus bp has to be equal to 0. 0, because we don't have any p's over here. So now, if I factor this out, b minus a equals 0. The only way that that's going to be equal to 0 is if b minus a is 0. And if b minus a is 0, then a and b are equal. So if a equals b, then we know that b is also 1 over 150. Now we have the numerators of our fractions. So I'm going to break up this fraction. I'm going to write that as 1 over 150 over p plus 1 over 150 over 150 minus p. Don't forget the dp here. 0.0015 dt. Okay, now I don't really like all these fractions inside of fractions here, so I'm going to multiply everything by 150. So I get 1 over p plus 1 over 150 minus p, and here's my dp. And when I multiply 0.0015 when I multiply that by 150, you end up getting 0.225. So this turns out to be 0.225 dt. Okay, now we're ready to integrate. So when I integrate both sides, then I will get the ln of p minus, the reason there's a minus here is because the derivative of this will give us a minus 1. So we have to introduce a minus 1 out in front of the integral sign. So we get ln of 150 minus p. And then on this side, we will get 0.225 t plus our constant. Okay, now, there's nothing wrong with this, but it makes our life a little bit easier if we do the following. I'm going to multiply by -1, and so I'll get the ln of p, ln of 150 minus p minus the ln of p equals -225t minus c. So just multiplying by a negative 1. And now I'm going to rearrange this using properties of logarithms as 150 minus p over p is equal to negative 0.225t minus c. And now I'm going to raise both sides using e as a base. Now the e and the ln will cancel out, and we'll be left with 150 minus p over p. And over here, we'll end up with e to the negative 0.225t and e to the minus c. Notice if the bases are the same, then we can just add those exponents. Now, we are told that when t is equal to 0, there were 6 guppies originally. So now I'm going to substitute these values into this expression. 150 over p minus p over p, which is 1, is equal to e to that power is going to be 1. And so then we get e to the minus c power. Now, I substituted a 0 in here. I'm also going to plug in a 6. So now I get 25 minus 1 is equal to e to the minus c power. So e to the minus c power equals 24. Now we just have one thing left to do. The problem gets a little bit long, but we have e to the minus c equals 24. So now I'm going to go back to this part here. We have 150 over p minus 1 is equal to e to the negative 0.225t. And then we just figured out what e to the c was, e to the minus c. That turns out to be a 24. And so now I'm just going to rearrange this equation and get p by itself. 150 over p equals 1 plus 24 e to the minus 0.225t. If I cross multiply and then divide, I end up with 150 over 1 plus 24 e to the negative 0.225t. And that's the equation they give you in problem number 33.